Remember conservation of energy, laws of thermodynamics, all that stuff from first semester? I'm going to demonstrate it in a fun experiment. The first law of thermodynamics states that energy is neither created nor destroyed, merely changes form. The two of these forms that are related to falling objects are potential energy and kinetic energy. Potential energy, in this case, gravitational potential energy, which is the energy of something not in motion. Gravitational potential energy is found by multiplying the mass by the acceleration of gravity by the height the object is from the ground. Kinetic energy is the energy of an object in motion. It is 1/2 the mass times the velocity squared. When an object is at rest, the velocity is 0, so the kinetic energy is also 0. This means that the only energy it has is gravitational potential energy, mass times gravity times height. As it falls, the potential energy goes down and the kinetic energy goes up, until right before it hits the ground, when the potential energy is 0 and it has only kinetic energy. We can demonstrate this with a ping pong ball, a golf ball, a super ball, basketball, and a tape measure, which is attached to a wall. On its own, a ping pong ball bounces to a height of about 1.7 feet. But put it on top of a golf ball, and it bounces about 2.6 feet. And put the golf ball on top of the super ball in a basketball, the super ball goes almost 5 feet, and the ping pong ball goes more than 7 feet. This is a large increase over the super ball's original height, and a huge increase over the ping pong balls. So why does this happen? When a ball bounces, its kinetic energy decreases, then increases, so it has the highest kinetic energy close to the ground. But when you drop two balls on top of each other, the first one hits the ground slightly before the second one, so hits the second one on its way back up, transferring the energy and sending the second one flying off, as you can see here. Think of it like the difference between hitting a baseball and holding a bat still while the baseball bounces off. Using the equations for energy, we can figure out just how high the ball would go. Because the total amount of energy never changes, the amount of energy at the top of the bounce, where it's all potential, and the bottom of the bounce, where it's all kinetic, are equal. If we substitute in the equations for the two types of energy and solve for h, we see that h equals v squared over 2g. This equation can be used to find the height to which a ball will bounce. But what about when there are two balls? The two balls are both traveling down with the same speed of v. However, the ball on the bottom hits the ground a fraction of a second before the one on top. It bounces back and is now going the speed of v in the upward direction. Because they are moving in opposite directions, the speeds of the balls relative to each other are now 2v. Assuming that, like a ping pong ball versus a golf ball, or a super ball versus a basketball, the ball on the bottom has a greater mass than the ball on top, it will also have a greater momentum. Because the ball on the top has so much less momentum than the ball on the bottom, it bounces off it almost as if it were a solid object. Therefore, its speed relative to the other ball is 2v, but because the other ball is moving as well, its speed relative to the ground, and us, is 3v. If we plug in 3v for v in the original equation and solve it for h, we see that h equals 9v squared over 2g. Since our original equation for the height of a single ball was v squared over 2g, we can see that by adding a second ball, it goes 9 times higher. This disregards friction and air resistance, assumes it's an elastic collision, meaning that no energy is lost, and assumes that the balls land on top of each other in a perfectly straight line, which I've discovered is pretty much humanly impossible, but it's a close approximation. More balls, greater difference in mass between the balls, dropping it from a greater height, will all increase how high the top ball goes. Can be a lot of fun, but I wouldn't recommend doing it indoors.
No, he's not in the picture. Baldrick, come here. Come on.
Baldric, go away.
There you go.
Crap, it's on the roof. I almost got it. Fence.
And it went over the fence.